Good morning, everyone. I am Bharat CS, uh, second year undergrad, studying in RYMC College in the branch of Computer Science and Engineering. Today, I am going to explain a very interesting topic, that is Windows 11 Security Architecture Overview. So, the contents of this topic are: the first content is Introduction to Windows 11 Security Features. Second content is Future Trends and Recommendations. Third is integration of TPM 2.0 and UBS in Windows 11. And fourth topic is user-based security mechanisms in Windows 11. And last topic is trusted platform module 2.0, TPM 2.0 deep dive. So the order is going to be we will start from introduction, and later we will go with trusted platform module 2.0. Then we will go study s- uh, some things on user-based security, that is UBS mechanisms in Windows 11. And fourth, we will study on the integration of TPM 2.0 and UBS in Windows 11. And fifth and last topic we are going to study is this one, future trends and recommendations. So let's start from introduction to Windows 11 security features. So the first topic is introduction to Windows 11 security features. So as you know, Windows 11 is a secure by design and secure by default, enforcing a robust hardware-backed security baseline on all new devices. All new Windows 11 PCs requires TPM 2.0 and secure boost at a minimum. This hardware root of trust ensures that firmware and boot code are verified. Before loading, Windows 11 also mandates virtualization support and turns on virtualization based security, that is VBS, and later hypervisor protected code integrity, that is HVCI. By default, VBS isolates critical processes like the security systems inside a mini hypervisor, so malware in the OS, main OS, cannot tamper with them. HVCI, that stands for Memory Integrity, runs the kernel code signing checks inside the isolated environment, blocking well or kernel tampering. Here, the first topic is security improvements overview. Windows 11 includes advanced protection, enhancing system integrity and data safety. And later, modern security architecture adopts a robust architecture designed to address evolving cybersecurity threats. And third is TPM 2.0 and USB integration, emphasizes hardware-based security through TPM 2.0 and seamless USB device management. Understanding TPM 2.0 in Windows 11. TPM 2.0 is a hardware-based security chip that ensures system integrity and trust. Hardware-level security functions. It provides encryption, secure boot, and platform integrity validation at the hardware level. TPM securely stores encryption keys and credentials, preventing unauthorized access. This secure baseline is complemented by identity safeguards and built-in protections. Windows Hello, biometric or PIN Hello, uh, replaces passwords for user sign-in, tying each user's credentials to a hardware key protected by the TPM. Enhanced uh, sign-in security in Copilot plus PCs adds even stronger protection for Windows Hello. Microsoft Defender Smart Screen provide phishing protection by warning users when they enter credentials on websites. The OS includes a full malware defense stack and secured core PC features, boot TPM and DMA protection, firmware monitoring, and stronger drivers signing rules. For example, kernel DMA protection is on by default to prevent evil-made attacks via external ports. And later, Windows 11 also incorporates advanced encryption and partition protection. BitLocker device encryption is enabled by default on most modern systems, protecting data at rest in case of theft. Windows Information Protection and Application Guard isolate business data and edge browsing. The Local Security Authority, that is LSA, is now protected by virtualization on new devices. Overall, these layered features, hardware root of trust, uh, virtualization, and code integrity, strong identity signing, and data safeguards make Windows 11 more secure than Windows 10. In practice, Microsoft reports a 62% drop in security incidents on Windows 11 relative to Windows 10, reflecting the effectiveness of these integrated protection. This is the overview of UBS. So UBS principles focuses on securing user identity through personalized authentication and access controls. On the year 2024, on the year 2025, UBS and TPM 2.0, UBS works alongside TPM 2.0 hardware to strengthen device and user security layers. On the year 2026, user identity enhancement, UBS improves access control by verifying user identity more reliably and dynamically. So our next topic is Trusted Platform Module 2.0, TPM 2.0, and deep dive. Here we can see the architecture of TPM 2.0. The first at the topmost is a hierarchical structure overview. TPM 2.0 features a layered design with modular components arranged in a clear hierarchy. Security function and modules. It includes cryptographic engines and secure storage to protect data and ensure integrity. And third, hardware and OS integration. TPM integrates tightly with both hardware and OS to enhance platform security. Here, TPM 2.0 functions are as follows. Secure boot and uh, ensures device integrity by validating firmware and system during startup. Storage, root key, and encryption provides a hardware-based key storage to protect data encryption securely. Firmware and OS integrity validation verifies the authenticity and integrity of firmware and OS components. Basically, the TPM 2.0 is a dedicated secure crypto processor on the motherboard that provides a hardware root of trust. It is tamper resistant, firmware and software cannot alter its protected function. Key TPM functions include generating and storing cryptographic keys, device authentication, and measuring the boot process. During system startup, each stage of the bootloader and OS is measured and recorded in the TPM platform configuration register (PCRS). These measurements act as evidence of system integrity. For example, BitLocker or device health can check that the expected trusted software was loaded before unlocking secrets. In addition, the TPM has a unique RSA key used to attest or identify the device securely. TPM protected keys can be sealed so they can work when the system is in correct measured state. Windows 11 required TPM 2.0 by default. Microsoft explicitly mandates TPM 2.0 for all new Windows compatible devices. TPM 2.0 is an evolution from older TPM 1.2 chips. Unlike TPM 1.2, TPM 2.0 supports a range of modern algorithms improving crypto agility. It also standardized the specification and offers a consistent lockout and anti-hammering policy. TPMs come in several forms: discrete chips, firmware, integrated into a CPU or chipset, or part of an SoC. Windows threads any compatible TPM identically, whether discrete or firmware. Security administrators should ensure that the TPM is enabled and active. Windows 11 checks for a security uh, processor version 2.0. In the Windows security apps, if none is found, that PC won't meet Windows 11's requirement. Since July 2016, Microsoft requires that all new Windows devices shipped with TPM 2.0 turned on by default. When a TPM is provisioned, an owner authorization value is set inside it. Windows 10 by 11. If a device is ever reinstalled or repurposed, the TPM can be cleared and reprovisioned per Microsoft guidelines. Then next is TPM 2.0 use cases in Windows 11 security. Disencryption with BitLocker, credential protection and authentication, and platform integrity with dynamic updates. The next topic is user-based security mechanisms in Windows 11. Though it has three concept and implementation. User-centric security model. The second one is identity protection rule. Third one is interaction with TPM 2.0. The first one focuses on securing users by isolating identities and managing access control efficiently. The second enhances identity safety by verifying user credentials and minimizing unauthorized access risk. Third, utilizes TPM 2.0 hardware to securely store credentials and support cryptographic operations. Then we have UBS access control and privilege management, role-based access, and second is user authentication flows, secure token and management. Before going to the next part, I just want to uh, um, go through the basics. Windows 11 enforces least privilege at the user level with features like user account control, UAC, and modern authentication. UAC runs application by default with standard user right, prompts for consent when an action requires administrative privileges. This means that even an admin user normally operates with limited rights, reducing the chances that malware can silently damage the system. UBS impact on user experience and security. First one is balancing security and usability. UBS in Windows 11 ensures high security without compromising user convenience and ease of access. Second one is minimizing attack surface. UBS reduces potential attack vectors by isolating user credentials and limiting permissions effectively. And the third is enhancing multi-factor authentication. UBS strengthens authentication through seamless integration of multiple verification methods for users. The next topic is integration of TPM 2.0 and UBS in Windows 11. First one is hardware versus user-based security. Second one is collaborative protection mechanism. Third one is strengths and complementary roles. Before going to the next topic, I just want to clear the basics. Windows 11 tightly integrates the TPM with its user-facing security mechanism. The TPM serves as the anchor of trust for user authentication, data encryption, and system integrity checks. For example, Windows Hello, PIN, and biometric credentials are stored as keys in the TPM. When a user sets up Windows Hello, Windows generates an asymmetric key pair inside the TPM. The public key is registered with account, while the private key never leaves the chip. Similarly, BitLocker device encryption uses TPM hardware. The volume master key is sealed into the TPM and only released if the machine is in trusted boot state. Security workflow in Windows 11. First is step-by-step validation. Second is boot time uh, and runtime checks. Third is data protection and identity. Real application scenarios. Secured enterprise environment, hybrid and cloud systems, modern threat detection. Next topic is future trends and recommendation. In 2024, anticipated enhancement and release, upcoming Windows versions will introduce stronger security features and better threat detection. In year 2023, shift to zero trust and AI security. Windows platforms are adopting zero trust models and AI-driven tools for proactive defense. Third is in the year 2022, evolution of TPM and UBS technologies. TPM and UBS technologies continue evolving to enhance hardware-based security protection. Best practices for leveraging Windows 11 security. TPM 2.0 activation guidelines. Enable TPM 2.0 to enhance hardware-based security and protect sensitive data against attacks. Effective USB integration. Implement USB policies that balance accessibility with strict control to prevent unauthorized device use. Updates and monitoring strategies. Regularly update system and monitor security events to detect and respond to threats promptly. There are some challenges and solutions in security adoption, deployment pitfalls, and second is user education, and third is Microsoft support tools. Okay, thank you so much for listening to this presentation. I am Bharat CS, studying in um, C section in the branch of computer science and engineering. So thank you so much for listening to this amazing presentation of Windows 11 security architecture. I hope you understood some things on Windows 11 security um, architecture. So thank you.